This presentation shall illustrate the general operation of the Megger MGFL100 ground fault locator. Before performing any ground fault tracing, we want to first verify a few items. First, verify the battery in the transmitter is fully charged if the unit is to be operated off of battery. To do this, turn on the transmitter and let it boot up. Verify the battery indicator displays a fully charged battery. This should be a green indication. If it does not, then charge the batteries, or you can operate the transmitter off of AC power. Next, verify the batteries in the receiver are good. To do this, turn on the receiver and let it boot up. Then, press the battery button. Verify the battery LED is green. If not, replace the AA batteries in the receiver. If you will be using the optional active mini CT, then be sure the battery in the CT is good. To do this, turn on the CT power. Verify the LED illuminates green. If not, install a new 9-volt battery. Now that we've verified the instrument is ready, we want to check the battery ground fault monitor. Battery ground fault monitors can have their own path to ground. This ground path will be in parallel with the unwanted ground you want to trace. If the impedance of the ground you're trying to trace is significantly lower than the impedance of the ground fault monitor, then this may not be an issue. In this case, the majority of the ground fault tracing current will still go through the fault. However, if the ground you are tracing has a higher impedance, then most of the fault current used for tracing will flow through the ground fault monitor and not the fault you're trying to locate. Therefore, it is recommended to isolate the earth ground from the battery ground fault monitor. Before starting any ground fault tracing, be sure to wear the proper personal protection equipment when connecting the unit and performing tracing. If you'll be operating the transmitter off of AC, then plug the power adapter into the transmitter. Then, plug the power adapter into an AC outlet. The power outlet must be from 90 to 264 volts AC, 47 to 63 Hz. If powering off a battery, the AC adapter is not required, and a fully charged battery should last approximately 4 hours. Now we are ready to connect the MGFL100. First, plug the green safety earth cable into the transmitter as shown. Then clip the other end to earth. A conduit is a good connection to use. This is a safety connection. This connection verifies that if anything fails in the unit, the case does not become live. Now, plug the green reference cable into the transmitter as shown. Clip the other end to earth. A conduit is also a good connection for this. Plug the black terminal cable into the MGFL100 as shown. Then clip the other end of the black cable to the negative lead of the battery string. Plug the red terminal cable into the MGFL100 as shown. Then clip the other side of the red cable to the positive side of the battery string. The MGFL100 can be used on battery strings up to 600 volts DC. There are also smaller clips available for small connection points. Now we're ready to apply test current and evaluate the fault. Turn on the MGFL100 transmitter and allow it to boot up. During the boot up, the following sequence will take place. First, all the LEDs will display 1888 for 3 seconds. This allows you to verify all the segments of the displays are operating. The firmware version will then be displayed on the lower left voltage display. The build number will be displayed on the lower right voltage display. After the boot up is complete, the lower left display will display the maximum voltage limit. This will be the maximum voltage output you'll be able to set on the transmitter. The lower right screen will display the maximum current output in milliamps. This will be the maximum amount of current you'll be able to get from the transmitter, and these values are programmable. The top 2 displays will display the positive and negative string voltages. The display with the lower voltage indicates the side of the string with the ground fault. So now we want to inject test current through that side of the string with the ground fault. Press the appropriate output button to enable the output tracing current. If the positive voltage reads lower than the negative voltage, then press the red plus button. If the negative voltage reads lower than the positive voltage, then press the black negative button. A countdown will ensue while the isolation caps charge up. This provides isolation between the transmitter and the battery string, and the countdown shall proceed from 10 to 0. Wait for the countdown to complete. The higher the voltage the transmitter is across, the longer it takes the isolation caps to charge. They need to charge to the level of the string. The charge time is approximately 10 seconds per 100 volts. Once the countdown is complete, the displays will display different values. The lower left display will display the actual voltage output of the transmitter. The lower right display will display the actual current output of the transmitter. Now, turn the voltage adjustment knob clockwise until the current reads approximately 5 milliamps. Note, if you cannot reach 5 milliamps, then the fault is a high impedance fault. Now, this is not a problem. However, when searching for a high impedance fault, it is recommended to view the actual measured values on the receiver's display and not to use the alarms as described later in this presentation. Now, note the readings on the top displays. The left display will indicate the resistance of the ground fault in kiloohms. The right display will indicate the capacitance on the circuit. Note, there is no problem if the capacitance reading displayed is 0. This just means there's minimal stray capacitance on the circuit. Now we are ready to evaluate the fault. Connect the current clamp to the receiver. Place the current clamp around either the positive or negative output lead, whichever one is outputting the current to the fault. Connect the sync cable between the receiver and the transmitter. Now, note the readings on the displays. The top display will indicate the current the fault is drawing. The lower display will indicate the reactive current drawn by stray capacitance on the circuit. It is the actual fault current on the top display that will be traced. Now, press the Save button on the receiver. This will save 3 values. The total current being drawn by the circuit, this will be the value that will be displayed if the sync cable is disconnected. The resistive current being drawn by the fault, or the fault current, and the reactive or leakage current being drawn by stray capacitance. These values can be recalled at any time by pressing the recall button on the receiver. Now we know the resistance of the fault and the current being drawn by the fault. We can now identify the circuit with the fault. So now set the alarm level on the receiver to 50%. This means when the measured fault current exceeds 50% of the saved value, an alarm shall be triggered. The alarm will only be triggered on the circuit with the real fault. Current drawn by stray leakage capacitance shall be ignored as long as the sync cable is connected to the receiver. The alarm can be either a visual-only alarm or a visual and audio alarm. Turn the dial to the blue section for a visual-only alarm. Turn the dial to the orange section for a visual and audio alarm. Place the CT around each wire of each circuit in the panel one at a time. Do not disconnect the sync cable. The top display on the receiver displays the actual current going to the ground fault. Locate the circuit drawing the most current as read on the top display. The alarm on the receiver will trigger when the measured current exceeds 50% of the saved value. Now that the circuit with the fault has been identified, we can start tracing the fault. Be sure to have a schematic of the circuit being traced. Now that we know the circuit with the fault, we can disconnect the sync cable from the receiver. The receiver will now only display the total current drawn by the circuit on the top display. This will be inclusive of both the current drawn by the fault as well as any current drawn by stray or leakage capacitance. The alarm will now be triggered when the measured current exceeds the selected percentage of the total current. You can push the recall button at any time to note the value of the total current. Using the schematic of the circuit, now start tracing the fault current through the circuit. Move the current clamp down the circuit to trace the fault. If the fault current is displayed on the top display of the receiver, then the fault current is still downstream. If the fault current is no longer displayed on the top screen of the receiver, then you've passed the fault. Use this technique to narrow down the location of the fault until it is located.